everybody, Mrs. Bowen here, and we're going to continue looking at Learning Target 4.2, where we're graphing a linear equation. In this video, we're going to look at part B, where we're using slope-intercept form to graph. So our directions for part B tell us to sketch the graph of each line using the slope and y-intercept. So in order to get started, our equation has to be in a specific form that we've talked about. For step one, our equation has to be in slope-intercept form. So I'm going to start off by writing that. Slope-intercept form. And as a reminder, I will write our slope-intercept form here. Slope-intercept form is y equals mx plus b. And we can make a note that m is our slope and b is our y-intercept, and I'm just going to abbreviate int for intercept. So once our equation is in y equals mx plus b, then in step two, we will plot our y-intercept. So plot our y-intercept. And we can make a note that this is the spot on our graph where the line crosses the y-axis. That's why it is called the y-intercept. Intercept means to cross. So this is the spot on our line where we will cross the y-axis. Once we have our y-intercept or our b plotted, then in step three, we're going to take a look at our slope. So we're going to start at this y-intercept. So I'll say start from our y-intercept and use our slope and use slope to plot more points. So just like we did in part A, we're going to plot at least 3 points in order to graph our line. So once we start from our y-intercept, we'll have 1 point, and we're going to use our slope to at least come up with 2 more points in order to graph our line. Let's look at example 4. So example 4 is already in slope-intercept form. Y equals 1/5 x minus 3. It's already in slope-intercept form. So I can jump right to step 2 where I'm going to plot my y-intercept. Well, what's my y-intercept? My y-intercept, or my b, is always the number that's at the end of the equation, the plus or minus a number. So my b is -3. My y-intercept is -3, which means I need to go to my y-axis, which is my vertical axis going up and down, and my line will cross my y-axis at -3. So I need to put a point at -3. I plotted my y-intercept, or where my line will cross my y-axis. Then in step 3, I'm going to start from this point, but I'm going to use my slope to plot more points. So what is my slope? Our slope, our m, is always the number that we see in front of x. So it is 1/5. We said that we like to see slope written as a fraction because it represents rise over run, meaning my rise is 1. So starting at my y-intercept, the point that I plotted, notice I am not starting from my origin, 0, 0. I'm starting from that y-intercept that I plotted. So if my rise is 1, I can go up 1, and then my run is a +5, so I can go right 5. So using my slope, I go up 1, right 5, and I can put another point. I could again go up 1, right 5, and I'd be somewhere over here off my graph, but I could put another point over here. There is another way we can think of this slope. This is a positive slope, right? Another way that you could think of this slope is to write it like this. The double negative turns to a positive. So this is the same slope. So if we start at our y-intercept here at -3, we could also go down 1 and backwards, or left 5. So down 1 and left 5. And we can double check. Does it look like our 3 points are forming a straight line? Yes, it does. We can connect our 3 points with a line, include an arrow on each end. And a good double check is if you look at the original problem, we saw that our slope was 1/5, or right here when we wrote it, we have a positive slope, 1/5. That means if you have a positive slope, it needs to look like your line is going uphill, or as you scan your graph from left to right, this line is slowly going uphill, or you're climbing up a mountain. So that's a good double check for you that indeed you did graph a positive slope. Let's look at example 5. And example 5 is an interesting one. It reads x equals -5. So we don't even have a y in this problem at all. And this is a special case. We talked about what some of our special lines look like in our previous learning target. But right here, this is saying that no matter where I look on my graph, x always has to be -5. So if you go to your graph, to your x-axis, and you go where x is -5, you don't just have a point here at x is -5. It means no matter where I look on my graph, x has to be -5. So what this ends up being is a vertical line going through x equals -5. So again, you wouldn't just have a point here where x is -5. This means no matter what y is, if y is up here at 4, x is still -5. If y is way off my graph up here at 10, my x is still over here at -5. No matter where I look on my graph, my x value will always be -5. Let's make a note over here on the side, since this is a special case. So when you have x equals some number, it's going to give you a vertical line. Versus, you will explore this on your independent practice. If you have y equals a number, that means you would go where y equals that number, and instead it's going to give you a horizontal line. We talked about vertical lines and horizontal lines when we talked about slope. So what we graphed here was a vertical line, and a vertical line actually has an undefined slope. And then if you have y equals some number and you get a horizontal line, that means you have no slope. It's horizontal, no steepness to it. So in that case, your slope is 0. So we did talk about what slopes would look like, but if you have x equals a number, it's a vertical line, and if you have y equals a number, it's a horizontal line. Let's look at example 6. So for example 6, I have this equation, -y minus 2 plus 2x equals 0. And right away I can tell this equation is not in slope-intercept form. It's not in the form y equals mx plus b. So before I can do anything, if I'm trying to graph using the slope and the y-intercept, I need to get it into that form. So what I'm going to do beneath my graph is I'm going to rewrite the equation to give myself a little bit of room here. And this is actually going to end up being review from our last learning target, where we would take equations and we would get them in slope-intercept form. So I need to get this equation to be y equals, and there's actually 2 different approaches you could take. I'm going to go with the approach that most students take, but at the end I will show you what the other approach was. So one way you could get this equation to be in y equals mx plus b is you could say, well, I need to move this -2 over to the other side, and I'm also going to need to move this 2x over to the other side. So I could first start by doing +2 plus 2, and I'll get -y plus 2x equals 0 plus 2 is 2. I need to move this positive 2x over to the other side, so the way I can do that is by subtracting 2x from each side, and I'll get -y equals, and I have to be careful, I cannot combine a constant of 2 and a variable, an x term here of -2x, so I just have to leave them how they are. And I'm going to choose to write my x term first. I'm going to write -2x plus 2. So notice I kept the signs. I kept it -2x, and I kept it a positive 2, but I'm writing my variable term first so that it will be like my slope-intercept form that I'm trying to get it in. And now I almost have y by itself, but I need to get rid of this negative out front. or this is like saying -1y or -1 times y. So in order to undo that, I would have to divide by -1 everywhere on every single term. So then I would get y equals, I'm doing -2 divided by -1, gives me a +2. So I have 2x. And then I'm doing 2 divided by -1, which gives me -2. So this is the equation that I need to use. Here's my equation in slope-intercept form. Y equals 2x minus 2. And what I'm going to do is I'm going to go up here next to my graph, and I'm going to list what's my b. My b is the number at the end here. It's a -2. What's my m, or my slope? It's the number here in front of x. So it's 2. And before we go to the graph, I do want to point out that there was actually a quicker way to do this problem. So if you ignore all this work and we look back up at the original problem, if you noticed that this right side only had 0, there was nothing there. And if I just did plus y to each side, then you would have had y by itself, and that would have been your only step. Then your equation would have been -2 plus 2x equals y, and you could just simply rewrite that, or if you could recognize that right then it was in slope-intercept form, and as long as you know the number in front of x is your slope, and the number that's plus or minus at the end, that's your y-intercept, then you're good to go. But I find most students are used to seeing y on the left, and so they naturally just move everything over to the right side. That's totally fine. This is great practice for you using inverse operations and getting y by itself. But if right away you noticed all you had to do was plus y, one step and you're done, you could have done that as well. Okay, so I'm going to, now that we have our y-intercept and our slope listed, let's just scroll up here or slide up here to example 6, and let's look at the graph. So now that we know what our y-intercept and our slope are, we can move on to step 2, and we can plot our y-intercept. So every time I list these, like in the first example up here, I like to list my b first and my m second. I like to list my b first and my m second. And the reason I do that is because that's the order that you're going to need to plot these on your graph. So first I need to plot my y-intercept, meaning where it crosses my vertical y-axis. So I need to go where y is -2, and I need to put a point. There's my y-intercept. Now I can use my slope to plot some more points. Well, when we're using slope, it's nice to think of slope as rise over run. But I don't have a fraction here. I just have the number 2. You can always write it as divided by 1, right? 2 divided by 1 is just 2. So you can always write it as divided by 1 so that you can see your rise is 2 and your run is 1. Or I'm going to go up 2, right 1. So starting from my y-intercept, the point that we plotted, I will go up 2, right 1. I can go up 2, right 1, up 2, right 1. I could continue. I will also point out that because this is a positive slope, the other way I could write it is -2 divided by -1, because a negative divided by negative does give us a positive. So if I wanted to use slope written this way, this would be down to left 1. So I could start at my y-intercept and I could go down to left 1. You'll see that these are forming a straight line, so I can go ahead, connect my line with arrows, connect my points with a line and with arrows. And a good double check, our slope was a positive slope, right? Either way that you look at this, this is a positive slope because you don't just have one negative sign here. Again, negative divided by negative gives you a positive. So if our slope is 2 or 2 over 1, it needs to look like we are climbing up a mountain or going uphill. And yes, it does indeed look like that. So example 4 and example 6 had positive slopes. Your line may not always be going uphill, right? If it's a negative slope, then it's going to be going downhill. All right, so at this time you have a U-try. Go ahead, pause the video and see what you come up with. Let's see how you did. And on this you try, I'm going to skip right to the equation to start. So our equation was not in slope-intercept form. So I had to use inverse operations in order to get my equation in slope-intercept form. I had to add 10x to both sides. Then I had to divide by -2 on every term in order to get my equation in slope-intercept form. So the line that you were graphing was y equals -5x plus 5. Once you come up with your equation in slope-intercept form, I always recommend that you go up next to your graph and you list what is your y-intercept and what is your slope. So my y-intercept is always the number at the end, the plus 5. So if my y-intercept is 5, then I can go to my graph and go to my y-axis and put a point here at 5, meaning my line is going to cross the y-axis at 5. Then I can go look at my slope. My slope is the number in front of x, so my slope is -5. And right here where I wrote my slope, I wrote it as -5 divided by 1. So similar to the last example, I like to see slope written as a fraction so that I can see rise over run. So the way I have slope written here, -5 divided by 1 would mean I go down 5, right 1. So starting at my y-intercept, I can go down 5, right 1, plot a point. I could go down 5, right 1 again, and plot a point. This piece right here, I would like everybody to write this on your page. This is a negative slope because there is one negative sign, and we could write slope this way that I just talked about, down 5, right 1, or we could go in the other direction, meaning instead of putting the negative sign in the top with the 5, I could put the negative sign in the bottom, and so I could go up 5, left 1. So starting from my y-intercept, I could go up 5, left 1, and I'd have a point somewhere over here. So you can use your slope going in both directions from your y-intercept. Both of these are a negative slope. Again, if there's one negative sign, it doesn't matter where your negative sign is. Your negative sign could be in the top, your negative sign could be in the bottom. And our last learning target, I often just pulled the negative sign out front, but only one of them can be negative if there's one negative sign. So you do have to be careful of this.